Assalamualaikum and good day everyone. We are Group 2 CEC 3C3 from the Faculty of Civil Engineering, UiTM Shah. Today, we will presenting our group assignment titled Integrated Sustainable Solutions for High Levels of Nickel Contamination in the Seas of Teluk, Bahang, Penang. Water pollution is a growing environmental challenge in Malaysia, particularly in coastal areas where marine ecosystems, fisheries, and local livelihoods depend heavily on clean water. Our presentation will cover the problem identification, causes and impacts, and an integrated solution approach involving engineering, policy, natural treatment, and AI technology aligned with sustainable development goals.
Teluk Bahang, located on the northwest coast of Penang, has recently drawn serious attention due to alarming level of heavy metals contamination, particularly nickel, detected in its seawater. Studies conducted by researchers from University Science Malaysia and Leto, reported by regional news agencies, revealed that nickel concentrations reach approximately 0.472 parts per million. This level is nearly 9 times higher than the natural background concentration of seawater, indicating a significant environmental concern. This contamination coincided with several critical impacts, including mass fish death, a decline in overall water quality, and severe economic losses experienced by local fish farmers who depend on clean marine conditions for their livelihood. Nickel is a toxic heavy metal that does not biodegrade and can persist in the environment for extended periods. Once released into marine water, nickels can accumulate in sediments and marine organisms, leading to long-term ecological damage and increased risk to both marine ecosystem and human health through the food chain. Why an integrated solution is needed? This issue cannot be effectively addressed through a single approach. Firstly, the exact source of pollution remains uncertain, making targeted action challenging. Secondly, the impacts of nickel contamination extend beyond the environment, affecting economic stability and public health. Finally, coastal pollution involves multiple stakeholders, including government authorities, industrial operators, researchers, and also local communities. Therefore, an integrated solution is essential. By combining engineering controls, strict regulatory enforcement, ecosystem restoration efforts, and AI-based environmental monitoring, long-term sustainability and resilience of the Teluk Bahang coastal ecosystem can be achieved.
Now let's talk about the analysis of causes. So the causes of the contamination in Teluk Bahang actually can be analyzed from 3 perspectives, which is physical, chemical, and biological. So first, let's talk about the chemical causes. So, nickel is commonly associated with industrial effluents, ship-related waste discharge, and metal corrosion and anti-fouling residues. Although there are no official source has been confirmed, but experts suggest that illegal dumping vessels passing through nearby shipping routes is likely to be a contributor. So how about physical causes? So, coastal currents can trap contaminants in semi-enclosed water. Limited water circulation increases pollutant concentration. Also, nickel tends to bind to suspended particles and sediments, making removal difficult. Now, let's talk about biological causes. So, through biological, nickel can enter the marine food chain through plankton. It can accumulate in fish tissues through bioaccumulation. So we know that bioaccumulation is very dangerous to the marine life, and also nickel can become more toxic under low dissolved oxygen conditions. These combined factors explain why contamination persists and intensifies over time.
Hi everyone! For this part of the presentation, I will be explaining the impact of nickel contamination. Although these issues sound technical, its effects are very real and directly affect to the environment, economy, society, and human health. Okay, first, let's look the environmental impact. The nickel contamination is toxic to the marine organism, especially fish and other aquatic life. It also puts stress on coral, reef, and benthic ecosystem, which are very sensitive to pollution. Over the time, this leads to reduced biodiversity and disrupts the natural balance of the ecosystem. So, even though the pollution may not always be visible, the damage underneath the water is so serious. These economic losses then lead to social impact. Loss of income threatens the livelihood of coastal communities. People also begin to lose trust in seafood safety, which creates a fear and uncertainty. As a result, communities may experience anxiety, dissatisfaction, and social stress. Okay, now let's talk about the health impact. Nickel exposure through contaminated seafood can cause allergic reaction as well as skin and respiratory problems. If exposure continues over a long period, it may lead to serious long-term health risks. This shows this issue is not only environmental but is also public health concern. In conclusion, nickel contamination is so serious problem that affect more than just the environment. It impacts the economy, social well-being, and human health. This highlights the importance of proper pollution control, monitoring, and awareness to protect both nature and the communities.
But what do we give back?
Now, I will present the proposed integrated solutions to address nickel contamination in the marine environment of Teluk Bahang. These solutions include engineering, policy, and ecosystem-based approach. The first solution is a smart marine water quality monitoring system. This system involves deploying sensor buoys to continuously monitor nickel concentration, pH, dissolved oxygen, and turbidity. The data is transmitted in real time to relevant environmental authorities. The sensors are calibrated to marine water quality standards, updated every 15 to 30 minutes and powered by solar energy. This enables early detection of pollution events and supports rapid and informed response. The key benefits include accurate monitoring, efficient pollution tracking, and evidence-based enforcement. The second approach focuses on policy and regulatory measures. We propose stronger enforcement of the environmental quality Act 1974, including mandatory waste reporting for vessels. In addition, higher penalties should be imposed for illegal dumping. Improved coordination among enforcement agencies will further strengthen compliance. This approach helps prevent pollution at the source, ensures legal accountability, and promotes long-term environmental compliance. The final approach is an ecosystem-based solution. This includes the establishment of marine protected areas and the restoration of mangrove forests and oyster beds. These ecosystems function as natural filters, reducing heavy metal contamination and stabilizing sediments. The benefits include improved water quality, enhanced marine biodiversity, and long-term ecological resilience. In conclusion, integrated advanced monitoring technology, effective regulations, and ecosystem rehabilitation provides a sustainable and comprehensive solution to nickel pollution in Teluk Bahang. Enforcement agency will further strengthen compliance. This approach helps prevent pollution at the source, ensures legal accountability, and promotes long-term environmental compliance. The final approach is an ecosystem-based solution. This includes the establishment of marine protected areas and the restoration of mangrove forests and oyster beds. These ecosystems function as natural filters, reducing heavy metal contamination and stabilizing sediments. The benefits include improved water quality, enhanced marine biodiversity, and long-term ecological resilience. In conclusion, integrated advanced monitoring technology, effective regulations, and ecosystem rehabilitation provides a sustainable and comprehensive solution to nickel pollution in Teluk Bahang. Thank you.
Artificial intelligence or AI can significantly strengthen sustainable environmental management when aligned with the United Nations Sustainable Development Goals, particularly SDG 6, 11, 13, 14, as well as Environmental Impacts Assessment Principle Number 6. By integrating historical data with real-time water quality monitoring, AI system can predict pollution events before they occur. This supports SDG 6 by enabling authorities to protect coastal water quality and prevent further heavy metals contamination. AI also helps identify high-risk pollution periods such as during heavy rainfall, extreme weather events, or seasonal ocean current changes. This supports SDG 13 as climate variability can significantly influence the transport and concentration of pollutants in coastal water. This proactive monitoring approach protects local fisheries and aquaculture activities, helping coastal communities remain resilient, economically stable, and environmentally safe. AI-based monitoring directly supports SDG 14 by reducing long-term ecologically damage, safeguarding marine biodiversity, and maintaining healthy coastal ecosystem. In line with EIA Principle Number 6, which emphasizes continuous monitoring and adaptive environmental management, AI allows authorities to move beyond one-time assessments. Instead, mitigation measures can be updated in real time based on changing environmental conditions. Overall, AI enables a shift from reactive response to proactive environmental management, improving efficiency, reducing long-term environmental and economic costs, and supporting sustainable coastal development in Teluk Bahang.
First, effectiveness. So, our proposed solution is highly effective because it uses multi-layer approach. Engineering system detect pollution early, policies prevent pollution at the source, ecosystem restoration supports natural purification, and AI improve prediction and response. Together, these layers provide strong and comprehensive protection for the marine environments. Next is feasibility. All components of the solution are technically achievable. The monitoring sensor, AI systems, and ecosystem restoration techniques already exist, so this makes solution realistic and practical to implement. Third is cost efficiency. Although the initial setup cost is relatively high, the solution leads to long-term saving. Next is sustainability. The solution is sustainable because it balances environmental, social, and economic factors. It protects marine biodiversity and ensures long-term economic benefits. Finally, legal compliance. All proposed measures fully align with Malaysian environmental regulation, particularly the Environmental Quality Act 1974, ensuring lawful and enforceable implementation. So, overall, this integrated solution is effective, feasible, and cost-efficient in long term, sustainable and legally compliant, making it a strong strategy and managing marine pollution in Malaysia.
For this session, I will explain how our project aligns with the Sustainable Development Goal or SDGs. Okay, first, our solution strongly support SDG 6, clean water and sanitation, as our main focus is reducing water pollution in Teluk Bahang and improving water quality to protect public health and the environment. Next is aligned with SDG 11, sustainable cities and community, because clean and safe water is essential for resilient coastal community like Teluk Bahang, especially for local resident, tourism and fisheries. Our approach also support SDG 12, responsible consumption and production, by promoting better the waste management, pollution control, and sustainable practice to reduce nickel and other contaminants entering the water system. Finally, it contributes to SDG 14, life below water, as controlling the water pollution help protect marine ecosystem, aquatic life, and biodiversity in coastal water. In conclusion, water pollution in Teluk Bahang is a complex environmental problem that requires an integrated, innovative, and sustainable solution. By combining engineering system, strong governance, natural treatment methods, and technologies such as AI monitoring, long-term environmental protection and community resilience can be achieved.